Okay, welcome everybody to our third meetup for Nix Your Bugs and Rust Your Engines. We are hosted again by the Engineering, Mathematics and Computing Lab of Heidelberg University. Stefan of the EMCL will also be joining us later, but unfortunately, during the same time frame we are here, he has to hold a lecture downstairs about IT security. Yes, first we will hear a talk by Moritz about procedural macros for network programming in Rust. Then we will have a few short Nix-related talks, and if you have any questions about Nix or NixOS itself that are bothering you while using Nix or that have prevented so far from getting into Nix or in NixOS, then you can also ask them here and we try to answer them together and look into them. And then afterwards we're all staying here, or who wants to can stay here to talk about Nix, Rust, NixOS or any related topic. Last time we were in Mannheim. We had a total of 15 participants hosted by the Raumzeitlabor. We had two talks. One was Fighting Cancer with Rust by Inola here, who I'm very glad also showed up today. You can find her slides in our metrics room, I think, and we also uploaded recordings of both talks to PeerTube, YouTube, and Anuga if you want to check them out. Our next meetup is still pending. We haven't set a date yet, or didn't even decide on a location yet. It will likely take place in Mannheim again because we're trying to have this pendulum between Heidelberg and Mannheim to cover the whole region. If you want to present a talk at a meetup here about Nix, Rust, or NixOS, or something that's related to that, then feel free to get in touch with me. And you can stay up to date to find out about the next event, date and location on our web profiles. We have a Mastodon profile, nixrust at rhein-neckar.social. We have a Mobilisor page, rhein-neckar.events/@nixrust. We have a metrics channel, and you can also contact us by email if you don't use any of these platforms. Fun fact, you can actually subscribe to our Mobilisor group as an RSS feed or a webcal calendar, so that might make it easier to integrate into other tools that you use. Since the last meetup, I'm part of Hackerstolz e.V., which helps organize events such as these. It's a non-profit association that focuses on teaching technology and programming from Mannheim. Membership for students is free, so if you're a student from, for example, Mannheim or Heidelberg University and you would like to join us, feel free to get in touch. You can find us on the web at hackerstolz.de. And we're also trying to establish a student association to get a better presence in the universities of this region. And small hint that's not directly related to this meetup, but at the end of May and beginning of June, there's the Gutfleisch Programmiernacht 22 in Karlsruhe. I'm pretty sure there will also be talks related to Rust or NixOS, so that's why it might be interesting. And you can find them on the web at gulas.ch, like goulash with a funny domain pun. And the entrance is free because it's hosted at a public location. Yeah, and now we set up our next speaker and then we can get started in 4 minutes.
All right, hi, I'm Moritz, I'm a master's student here. I'll talk a bit about procedural macros for network programming, but it's really about everything else, so I'm not going to talk that much about network programming, it's just a small motivation. I'm really just going to give an introduction to this feature of Rust. Before we start, who would call themselves experienced with Rust? That's pretty good. And who knows what procedural macros are and who has written them? That's pretty great. Okay, perfect. All right. So what are macros in general in programming? It's pretty different between languages. In C++, it's glorified inline functions without type information, so it's really not a particularly great feature for anything complicated. In Rust, there's way more that you can do with macros. They're basically just programs that you can execute at compile time that generate code. So if you have written a hello world in Rust, you have used macros, but not necessarily proc macros. The print macro is a declarative macro. They are very different in that they work similar to a match statement. So they match what is inside the brackets, inside the parentheses, and you can specify rules how this text is supposed to be expanded. Proc macros, on the other hand, are usually used first when you declare some struct and you want to print it, and the compiler yells at you and tells you that you have to implement debug, and then you just slap this on top of your struct, and it will automatically generate the debug trait for you, which means automatically generate a function that lets you print a struct that is called here. So how does this look like? This is what the compiler actually generates when you expand it. You can see here that it uses something that you would in Java maybe do with reflection or whatever, but at compile time can still see the names of the types and everything and can put them here as strings, and so it generates you this function. So why do you want to know anything more than that I can derive debug? For motivation, when I did a practical, I'm still doing it here at the university, I was working with the quick network protocol, and I had to check if packets I received were actually valid quick packets and if they contained the correct data. And what I did first was I used the quick library and I made everything public, like I forked it and made all the methods public that I can use to dissect the packet, and it's kind of terrible because then I have to include this huge library in my code. But I don't want that, so instead I realized this library pnet provides a pretty nice alternative. So in general, it's like a networking library that implements UDP and IP like utilities to work with these packets, to dissect them, but it also provides a procedural macro. This you can use to automatically generate a lot of boilerplate code that you maybe don't want to write. In essence, this is the quick packet, the specific quick packet format I need to parse. It's just a struct with a bunch of numbers. Here it specifies a length field that specifies how long this value will be. And then by using pnet, I can annotate this as such. I can here add this decorator that says I want to derive the packet trait for this struct. And then I have to specify some other things, because when I have a vector, I have to specify how long it will be in some way or another. And in this case, I can specify this length attribute. And this at compile time will pass this struct. And then when it encounters something like this, it will look at the fields that it has already passed and see if this identifier is present in the field names. But you can also specify arithmetic expressions that consist of field names, constants, and literals. So it's quite flexible. And if this isn't enough, you also have the option to specify a length function, which takes in a packet like this and then is called on this packet, or rather on the partially assembled information from the packet that you have at this stage. You have to be a bit careful. I tried to implement something a bit more complicated with this. And then it can happen that you have like a recursive function on accident, because it tries to call stuff it doesn't really have access to, and then you generate something that overflows your stack. But nonetheless, it's really flexible, and you can specify, you can pass, you can skip implementing a bunch of code that transforms from a byte string to these packet representations. You also get like mutable accessors that you change values on the byte string that correspond to these fields on a packet, and so on. So it's really convenient. It drastically reduces code size. But if you don't need like these fine-grained controls about, like if you don't need single bits, for example, if you're fine with handling these stuff like this yourself, or if maybe none of your values in your struct are non-multiples of 8 in size, then you can also use the zero copy crate, just like crate by Google, and they do more extensive stuff. I'm not going to really talk about them, but their traits are simpler, but they put a lot of work into ensuring that everything you do is completely safe, with a lot of annotations and stuff. It's an interesting crate, but it basically provides the from bytes and the as bytes traits and the corresponding declarative procedural macros that let you derive them. Then you can specify a struct, say from bytes, and then if you have a byte string, you can transform it into the struct. Yeah. So now, how do they work, or how do I implement them, and what kind of macros are there? The procedural macros are split into 3 types. We want to have function-like proc macros, which look exactly like declarative macros when you invoke them, which is a bit confusing, I guess, because you never 100% know before looking at the code what kind of macro you're calling. Yeah, but their syntax is the same, but they don't work the same. More on that in a second. Then there are derived macros. These are the ones pretty much everyone has used at some point if they programmed in Rust a bit, where you can specify traits that are, well, not really traits, but stuff that you can derive for your packets, for your structs. And then you have attribute macros, which this is probably one of the more common ones. The macro you can use to annotate your main function to be executed asynchronously by Tokyo. Not really important exactly what it does. But in this talk I'm going to focus mainly on derived macros and how they work, because they're really similar. They're basically, all of them are basically work the same thing, they just have slight differences in what you get. Basically here you get everything that's inside the parentheses. Here you get the struct it's placed on, but you can only place it on structs and enums and unions, and then with attribute macros you can place them on most things that Rust considers an item. Yeah, and you also can add arguments inside here that you can also pass inside your macro. So this is how you declare or define a derived macro. You have to add this attribute, and then here you can give the name that the user will have to add inside the parentheses in the derive call. And this takes a token stream, and it produces another token stream. So a token stream is like Rust syntax, and you take in everything, the syntax of the object you're annotating, and then you do whatever with it, and then you output it. With derived macros, it doesn't overwrite the tokens that were there, because then the struct would disappear, but it adds it below the struct you annotated. So how do these token streams look? So if we again have this point struct that we had at the start with 2 fields, then token stream looks a bit like this. We have an identifier for struct and an identifier for the name of the struct, and then we have a group, which is these parentheses, these curly braces, and the content of them. And there's this stuff like punced is what it's called if you have like colons. And this, I mean, you don't really want to work with this. At least I don't want to work with this, because it's you can barely decide if you have like a name of something or a keyword. So yeah, this is really annoying to work with, because you want an AST, you want an abstract syntax tree, because tree structures are great, and also you want to have stuff like this actually be something that resembles a struct, or is at least identifiable as a struct uniquely. So this is where the syn crate comes in, and the quote crate will also come in later, which is the 2 big crates that are usually always used by a library that implements a proc macro. Yeah. So yeah, and syn lets you create a cool tree from the token stream, and then quote lets you assemble token streams in a nice way. And yeah, both of them use macros again, especially quote. So yeah, macros are always the solution in Rust. Yeah, so yeah, this is more like what syn gives you after you pass the token stream. This is slightly, I guess, simplified, because you really, like this for example, this data is an enum, so I didn't, like a data carrying enum, so an enum that has a struct in each variant. I just left it out, but basically you have your input to a derived macro, which contains data and an identifier, in this case the name of the struct. Yeah?
I'm not sure if you want to take questions now or later.
It's fine.
Okay, perfect. Do you know of a tool to visualize stuff like you did here? Is there something?
This I made myself by hand, yeah. So no idea, sorry.
Okay, yeah, thank you.
But I would be interested as well. Yeah. So yeah, so you have like the name of the stuff you annotated and the data, and then you get, okay, this is a struct, otherwise it would be an enum or whatever, and then you have the fields, and you also have something that's called a span, which I won't go into detail too much, but it's basically if something fails with the thing this span belongs to, then this span gives you information for where this came from. So which part of the user written code is responsible for this error, so that when the compiling fails, you actually see where you went wrong. So you can basically choose, as the developer of the proc macro, what code influences this and where the error should be coming from when whatever you're doing doesn't work. And then this is like, sometimes like after an if statement there can be a semicolon, but doesn't have to be, so this is an option. It doesn't really matter. But then you have the fields, which again are slightly simplified here. There's really like, this is another enum because there's a bunch of different ways for types, but all in all it's all well documented how it works, and you can just pattern match against all these things to get exactly what you want and fail otherwise. So yeah, so let's so let's just try to write our own version of the derived debug macro. A simplified version, we will just only work with structs because the code for enums and unions is more or less just duplication, but slightly different pattern matching. But yeah, so first of all, you use this macro that is provided by Syn for us to get this tree from this token stream. And then this is exactly this data structure that I showed there, except not simplified, but then when we parse it, we do something like this. This is a bunch of code, and it looks maybe slightly convoluted, but you really just go through this stuff with Rust pattern matching. It's just, if this matches, this has exactly this structure, then we will assign a reference to the field named in this struct, which just means if this is a struct that is carrying named fields. I'm honestly not quite sure what structs with unnamed fields are.
It's the tuple structs.
Right, yeah, that's probably it. And then you get a reference to these fields that you can then use inside if body. And if this is not the case, in our case, we will just panic because it's at compile time. So panic is really just abort compilation and throw an error. So now how do we use these fields to actually construct our format, print, whatever method to implement the debug trait? And this is, okay, for this we use the other trait I mentioned, which is quote. So we use a macro to transform literal Rust code into a token stream. So we can just actually write Rust code inside our macro that's then transformed into a token stream. So this works. First, you can just ignore this. This just gets the field identifiers and the string versions of the identifiers because we want to also print the names as strings. But just ignore this. This holds the actual identifiers, which are a different object than the stringified names. But then we can use quote to do this. We say we want to implement the format method. And then this works. As we saw the first slide, this has this formatter has a debug struct method where we then insert ident string, which is the stringified version of our struct identifier, because this needs the name of the struct as an argument, as a string. And then here, this is a bit complicated but really cool syntax. We have two lists that have the same name. And then we can, this pound and the brackets and the star then specifies interpolation and repetition. So this iterates through these lists, and then for each element in the list, or in both lists, like it's like a zip in Python, it generates this statement with one element each inserted. So it generates .field, then the stringified version of the field name, and then we take a reference to self and return the value of that field. This is why we need identifier here, because this is supposed to correspond to the actual code we write if we want to get a reference to a field from a struct. So this then generates this list of arguments. Yeah, exactly. This might be a bit confusing, like looking at it, but yeah, once you use it three times or something, it's really very comfortable. So now, how does it actually work? How are these things compiled? Because what I would expect would be this. We have our proc macro crate. They have to be their own crate. They can't be, you can't export proc macros from crates that export other stuff. So I thought it would compile the crate, and then the actual program sends the stuff inside the macro, so the token stream, to the library, and the library gives me the token stream that is expanded. But this is not how it works, due to the application binary interface of Rust, so how you can interact with how you can interact with other libraries. This is really unsafe, and so at least not quite specified. And therefore, they require this. So basically, we have a proc macro server, which is your program that's being compiled, and the client is the proc macro library. And then for each, then like the server creates handles to the stuff that is supposed to be expanded. And then instead of sending all the tokens to the client, it just sends a handle. So at the start, it sends a handle to the whole thing, basically a handle to the token stream. And then if the proc macro calls into ether, for example, on this token stream, it instead calls it on the handle and sends the server call this on whatever is behind that handle. And the server does this and returns the handle to the result of this operation to the proc macro. So the proc macro never has the actual values, but it always has the handles to all values it currently has access to, so it can perform these operations nonetheless on the handles and tell the server what it has to do. Yeah, and this is kind of confusing, at least to me. It seems a bit too complicated, but apparently it's very necessary. Yeah.
So are those boxes like threads, processes? What are the?
This is like a dynamic library, so some shared object, and this is the Rust C compiler while it's compiling. Okay. Yeah, so it's communicating with this library. Yeah. So now we're done with the programming and internals part. I'm just gonna say a few finishing thoughts on how you, like some tools that are provided. First of all, there's cargo expand, which I also use to get like the expanded version of the code at the start. So you can just call this in a program and it will expand all your macros and give you the output of the macro expansion. And you can also, of course, specify a module or whatever that you want to expand or test, so you don't get too much stuff. And then there's Rust Analyzer, which probably everybody knows that does Rust, or at least it's really good, so you should use it. It's like the language server for Rust, the main one, and it also wants to support code completion and stuff for proc macros, but it can't just do it. Yes.
Yeah, another question. Is it also possible to expand only specific macros and get the output from that? Does cargo expand to that as well?
Maybe, but I don't. At least they don't really advertise it, so I don't think so.
So probably not.
Yeah.
Also,
I don't know how it would work.
It's like if you try to expand a single macro, it still requires the input to expand into something. So if you just point to a macro, what would you expand to if he doesn't know what the input? So it has to be, I think, a module or a function.
You may only be able to expand the inner macros before you can, and then
okay. Would be.
But yeah, that's right.
Okay. But this, because of this weird communication between the proc macro, it can't just easily do this. So instead, it implements Rust Analyzer implements its own macro server to do the same communication, but instead use the results it gets to provide completion and lexing on the end, whatever. Which is really cool, because now if you annotate, you derive this this packet stuff, for example, you immediately get completion for all the stuff it generates. because it runs cargo check in the background to compile the proc macro crate, and then it communicates with the crate via the server they implemented. Yeah. And I think that's probably it. Yeah, that's it. Thanks.
How do you debug generated code? Because if I remember correctly, when I played around with proc macros, I had a syntax error somewhere, and I had a line with 10,000 characters, I think, and it pointed me to the right at the end, and it was really difficult to debug.
Yeah.
How do you handle that?
I think it's like a combination of, first of all, always doing something like panicking if you reach problematic stuff, so it never goes further. But also using these spans, so always putting these spans at everything you generate properly. Yeah, because then it can usually point to where you want to go look for the problem. But I also had, I haven't done anything crazy with these macros, but I also sometimes had problems where I was like, I don't even know what it complains about. It definitely happens.
Yeah, I had a proc macro that had an input file as its argument, and I wrote that, I passed it, and I generated a custom parser from that, which had a few thousand lines. So a syntax error, a missing comma, whatever, down the line, really is not fun to debug.
Yeah, that sounds pretty horrible.
Okay. So you don't have any magic tools for that.
I definitely don't have any magic tools for
You
that. Sorry.
get really desperate. You in the part when you call quote, and then you produce like there's a bunch of tokens. You can call toString on that, and then just write to a file, then grab that file, put it like expanded into your stuff, and then you run the compiler on that.
The issue with that was I tried that and I wanted to format the file, but lost format expects the source code to be valid for formatting. So okay.
Yeah. No.
So in the end, I just selected all curly braces, opening braces, and hit enter, and added line breaks everywhere. So that was a bit easier to debug.
Good.
The problem of 10,000 characters single line is somewhat fixed by being able to use the quote crate. Because you can literally write the block of Rust code you want to emit, parameterize.
Yes, but in the end, it's always tokenized. So the token stream that I emit is then, and if the token stream has some issue, I think, then it was
If
difficult.
token stream is invalid, then
So it should not be possible to have like a mismatched query breaks in quote, I think.
Yeah, that's
I mean, quote for sure doesn't generate invalid token streams, right? Because they check it. But yeah.
okay.
They might still be like typed invalid in some way.
To what extent is this a security concern, or does it increase the potential attack surface for your program, and what measures would you need to take to?
I mean, I would say it doesn't really, like if you don't do like crazy side effect stuff like reading files inside your proc macros, then it's probably fine because the compiler usually checks most things. But if you do stuff like this, I don't know, but it's probably fine-ish, I'd say. I don't think it's like a huge risk.
It's basically only an issue only when you start using third-party crates, because I mean, open source crates, you get the option of checking the source code if you're down to see that it doesn't try to erase your home directory or something, because it could during the build process. There was a controversy last year where one of the most used Rust libraries, CLB, added a binary to the crate, which was also included in the repository. With the reason being that Vitali, who's also the author of Prot and Proc Macro 2, wanted to reduce the compile times added by Proc Macros. But in the end, unless these binaries aren't produced transparently in some pipeline in this repository, you can't be sure what's included, which was the case here because it was just a binary in the repository.
So if I understand correctly, that means macros are not sandboxed.
No. I mean, that's
so
part of the compilation pipeline.
in theory, I could derive, say, Zero deserialize, and somehow my struct is being augmented with a send to the server.
Yeah, I mean,
in JSON because of Zero.
I mean, yeah, you could if the side crate, yeah, sure.
somewhat helps if you have a magnetic build system like this.
Oh, look at that.
For us, the CD crate with the binary caused huge issues in our CI pipeline because we couldn't build them in Mix because this library was trying to access glibc, which didn't exist at the path we expected in our Mix build environment. So we just failed during the build for trying to execute this binary.
There's also a different place where you can just execute random code that is during the actually resolving of the proc macro. You can just call out outside of the system. You can do network calls if you want.
So it just does.
Yeah, I also used it for the purpose. Not to network, but at least running external services.
But then to be fair, Vue.rs can do anything too, right? So if you
But I thought we limited the sort of build time shenanigans to build.rs.
yeah, I guess. But
Because now you can have it wherever you want at any point of your crate.
Yeah.
The build.rs was meant to be this singular entity where if something does call something outside the system at build time, it will be here. But it's not.
Sure.
Well, okay, but like that in general sounds more like a imperative language programming problem than a Rust specific problem.
Yeah, it's a Rust problem. Right.
Like wouldn't happen in Haskell, for instance.
Wouldn't happen in C either, because it simply wouldn't work though.
Yeah, but C macros are just copy paste.
Exactly, it wouldn't work.
I think the problem is a little bit that you have hundreds of dependencies usually in even little projects, and hundreds of build.rs files lying around, and I think this is what I thought not so secure. Something like this except library hack is there, somehow easily to inject.
There were efforts to start sandboxing the execution of proc macros in some kind of WebAssembly environment, but from my latest knowledge, that didn't pick up any real progress.
Isn't that what resulted from the Ptolemy's
Actually,
shenanigans?
it was the other way around. He told me he had a crate for sandboxing proc macros in WebAssembly, and then for whatever reason dumped that and decided to add random binaries to the CD repository.
Probably too close to the RFC.
Maybe.
I did a little experiment, and Rust Analyzer actually publishes its proc macro server, and the goal I had was actually to cache essentially the compilation of proc macros, and then execute a binary, which will then execute Firecracker, which will then execute the actual proc macro. So if you want to try to write an HTTP service that just outputs proc macro code or something, you can do it. And Rust Analyzer really has a great API. If you just want to use it as a library.
Cool. Okay, that's all. Again, thanks a lot for this great talk. And we are having a half-hour break, and then we continue with the next part of this evening.